A car of mass 1600 kg moves with a constant power of 14,000 kilowatts as it travels along a straight horizontal road. Okay, let's make this. Okay, so it's moving in this direction. Then this would be the driving force, and driving force is power upon speed. So it's going to be 14,000 upon V. Okay, so next, it says that the car takes 25 seconds to travel from point A to B. Find the work done by the car engine while the car travels from A to B. Okay, so the formula for work done is, or the formula for power is equals to work done over time taken. So power into time would be work. Power is 14,000. Time in seconds is 25. This should give us the work done. Work done would come out to be 350,000 joules or 350 kilojoules. Okay, this is the work done by the driving force. Okay, or the work done by the car's engine. Okay, part two says that resistance to the car motion is constant and is equals to 235 newtons. The car has acceleration at A and B of zero point 0.5 and 0.25 respectively. Find the gain in kinetic energy by the car in moving from A to B. Okay, what do you do for part two? You apply Newton's second law on this twice, once for A and once for B. So for A, forward force is 14,000 and we know the speed at A. No, we don't know the speed at A. Let's call it VA minus the backward force is 235 is equals to mass times the acceleration at A is 0 0.5. Okay. Do the same for B. Forward force would be 14,000 upon the speed at B is VB minus backward force is the same is equals to mass times acceleration for B is 0 0.25. Solve both of these, get the value of VA and VB. They come out to be 13.35, sorry, 13.53 and 22.05. Okay, now we need the gain in kinetic energy. So it's half m, half times m is 1600 times brackets bigger speed squared minus smaller speed squared. Okay, this would come out to be 242.5 kilojoules. So 242, sorry, let me just find this. This would be 0 0.5 into 1600 times brackets 22.05 squared minus 13.53 squared. Okay, I'm getting 242513.28 joules. This is the difference in kinetic energy, change in kinetic energy. You may divide it with 1000 and write 242.5 kilowatts as your rounded answer. Okay, part 3 says find the distance AB. Okay, now I'm going to use the work energy principle, which is work done by driving force plus gain in energy is equals to work done by resisting force plus loss in energy. So work done by driving force is this, we already found it, 3500,000 plus gain in energy is the gain in kinetic energy already found 242,513.28 joules is equals to work done by resisting force. Okay, we know the resisting force 235 and we know the distance it covers. That is what we have to find, D. So work done by resisting force, we're using the formula force times D, and the resisting force is 235, and D is what we have to find. Plus loss in energy, there's no loss in potential energy because it's a horizontal surface, so there's no gain or loss in potential energy, so this is also zero. Okay, now you make D the subject here and get its value. Okay, there's four zeros over here, not five. Okay. When you make D the subject, you should get. Okay, there's a big blunder here, very big blunder here. Work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. So this will have to be fixed. I'm very sorry. Okay, work done by driving force is the same, but the loss in energy is zero. So this doesn't come here. There's zero here. Is equals to work done by resisting force is the same, but the gain in energy was supposed to be written on this side. That was a big blunder in formula. Okay, now you make D the subject. So you will subtract this 350000 with 242,513.28 and divide the answer with 235. Then you'll get the right answer. I'm getting 457. Rounded to 457.